Rogini College of Engineering and Technology. I am Selvi, Assistant Professor, Department of Physics, Rogini College of Engineering and Technology. In this video lecture, I am going to explain infrared radiations and its application. Infrared radiation are also known as thermal or heat waves. The range of wavelength is between 710 millimeter to 1 millimeter. The rays also characterized as near and far infrared rays. The near infrared rays have use in photography and TV remote sensor. Far infrared rays are thermal. The human body also generates heat or infrared radiation of approximately 800 nanometer wavelength. Infrared rays have lower frequencies and photon energies than visible light. They are associated with thermal radiation and are commonly used in night vision, remote sensing, and infrared spectroscopy applications. Infrared radiation wavelength and frequency. We already know that the wavelength of infrared radiation is between 700 nanometer to 1 millimeter, which is between the red limit of the visible spectrum. But the following is the classification of band based on the spectral range 1 micrometer and 50 micrometer. 1 micrometer to 3 micrometer, which is known as band 1 or short wave infrared. 3 micrometer to 5 micrometer, which is known as the band 2 or middle wave infrared. 8 micrometer to 14 micrometer, which is known as the band 3 or long wave infrared. Characteristics of region of infrared. Near infrared, the wavelength ranges from 0.75 to 1.4 micrometer. This is used in material science, fiber optic communication, and in the medical field. Short wavelength infrared. The wavelength ranges from 1.4 to 3 micrometers. This is used in telecommunications and for military purposes. Medium infrared. The wavelength ranges from 3 to 8 micrometers. This is used in the chemical industry and in astronomy. Long wavelength infrared. The wavelength ranges from 8 to 15 micrometers. Astronomical telescopes and optical fiber communications are possible with the help of long wavelength infrared. Far infrared. The wavelength ranges from 15 to 1000 micrometer. It is used mainly in the treatment of cancer therapy. Absorption and reflection. The absorption and reflection of infrared waves depends on the nature of the substance that the waves are made to strike. Materials such as ozone, carbon dioxide, and water vapor absorb infrared radiation. Snow and aluminum foil are materials that reflect infrared radiation. Application of infrared radiation. Heat source. Medical sector and manufacturing industries use this radiation as a heat source. The infrared saunas that treat rheumatoid arthritis, high blood pressure, and other chronic health problems. It is also a safe method for physical therapy. The manufacturing unit uses infrared heater in curing of coating, the formation of plastics, and plastic welding. Cosmetology. We use this radiation for treating dandruffs, skin injuries, blackhead, and smoothing wrinkles. They also improve oxygen supply, blood circulation, and supply of nutrients to the skin. Astronomy. Astronomers use optical devices like digital detectors, mirrors, and lenses to analyze space objects via infrared waves. We can obtain the images of these devices from the infrared telescopes. Massage therapy. This radiation warms the skin and helps to relax the muscles. We use them because of their penetration attribute. Infrared photography. The infrared filters can capture pictures. The imaging is performed for objects in the near infrared spectrum. Infrared communication. The transmission of data through infrared rays is quite common in the communication of the short range. We utilize the light emitting diodes for emitting this radiation. Further, the focus is done on a narrow beam with the support of a plastic lens. At the end of the receiver, the photodiode converts radiation into electric current. Thank you.